All right, good morning, guys. Today we're going to be covering the Unit 7 whiteboard review. So let's go ahead and jump right in. So these three assignments, these are the three things that you guys should be studying for this Unit 7 test. Again, all these can be found in Schoology. The formative assessment as well as the review, those are both on Tuesday. This is also known as the practice test. And then we covered that on Tuesday. And then the whiteboard review is what we're covering today in class. So getting started, we're going to go ahead and find the distance between these 2 points. We have the point -2, 5 and the point 3, -7. Now, in order to find the distance between 2 points, we're going to use the distance formula. Distance formula being x2 minus x1 squared plus y2 minus y1 squared. You take that sum and you take the square root of it. That'll give you your distance. Again, this is just derived from Pythagorean's theorem. So taking our 2 points, x1, y1, x2, y2, I plug them in. This will give me 3 minus -2 squared plus -7 minus 5 squared. Double negatives turn to a plus, so 3 plus 2 is 5. So I have 5 squared minus plus -12 squared. 5 squared is 25. -12 squared is 144. 25 plus 144 is 169. So we have the square root of 169. Lastly, just enter this into your calculator. It'll give you your final answer as 13 units. So the distance between those 2 points is 13. All right, next up, let's go ahead and find the length of the diagonal of the rectangular solid. So first off, if I'm trying to find the diagonal here, I'm trying to go from one point of my rectangular solid through to the clear opposite point. So I'm going all the way through my figure, all the way through the solid here. So that's what we want. Now, since I know that this is a right triangle, I can use Pythagorean's theorem to solve for it. So that would give me x squared plus 6 squared equals y squared. I'm saying that this is also 6 because it's a rectangle, and I know that opposite sides of rectangles are congruent. Now, I don't know what x is yet, so I need to solve for x first. So I'm going to go ahead and use a right triangle on the bottom here, on the bottom face. So that'll give me 4 squared plus 10 squared equals the hypotenuse x squared. 4 squared is 16, 10 squared is 100, 16 plus 100 is 116. Taking the square root of 116 will give us x. Therefore, x is equal to 2 radical 29, which is about 10.8. Now that I have x, I can go ahead and use Pythagorean's theorem on this other right triangle, the one for the entire solid. So that'll give me x squared, or 2 radical 29 squared, plus 6 squared equals y squared. Six squared will give me 36. 2 radical 29 squared, well, that'll just bring me back to 116 equals y squared. 36 plus 116 will give me 152. If I take the square root of both sides to get y isolated, that'll give me y is equal to 2 radical 38, which is about 12.3 units. All right, next up, we're going to find the perimeter of an equilateral triangle with a height with an altitude of 18. So to do this problem, the first thing that we're going to do is we're going to draw out our triangle. And again, we know that it has a height of 18. Since this is equilateral, I know that each angle is 60 degrees. All angles and all sides will be congruent. So therefore, this height here is splitting this top angle, the 60-degree angle, in two, making this into a 30, 60, 90 triangle. So therefore, I can draw a corresponding 30, 60, 90 triangle and map up my corresponding parts. Looking at this, the only side length I have is 18. 18 is opposite 60 degrees. Side opposite 60 degrees in my corresponding triangle is x radical 3. Therefore, 18 equals x rad 3. From here, I can solve for x, and that will give me the bottom portion of my triangle. So solving for x, I can do that by dividing both sides by radical 3, and we'll be left with x is equal to 18 over rad 3. I'm going to rationalize this denominator by multiplying both the numerator and denominator by the denominator, radical 3. That'll give me 18 rad 3 over 3. Since both numbers in blue, 18 and 3, are not underneath the radical, I can divide them. 3 will go into 18 6 times, giving us our final answer of x being equal to 6 radical 3. which means that this bottom portion here, just from the corner to the center, is 6 rad 3. But again, we need the full thing, and if this is only half of it, 6 rad 3, then the full thing must be 12 rad 3. And since this is equilateral, that means that all three sides are the same. They're all 12 rad 3 in length. If I'm looking for the perimeter, well, that means I have three sides that are all the same length. So 3 times our distance of one side will give us the perimeter. So therefore, our perimeter is 36 radical 3. Of course, if we want to round this to the nearest tenth, that'd be 62.4. That's our final answer. All right, next up. Given W is at the point 2,4, O is at 10,6, and L is at 4,9, F is the midpoint of WO. So F is the midpoint of this segment right over here. We would like to find the coordinates of F. Now to find the coordinates of F, we're going to use the midpoint formula because F is the midpoint. Midpoint formula is just the average of our X values and the average of our Y values. So if I take the average of my X values, 2 plus 10 is 12. 12 divided by 2 is 6. For my Y values, 4 plus 6 is 10. 10 divided by 2 is 5. Therefore, our midpoint is the point 6, 5. Next, we need to find the length of the median from point L to point F. So we'll use the distance formula once again. Distance formula is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. Plugging in the points L and F for x1 and x2, as well as y1 and y2, this will give us distance is equal to the square root of 4 minus 6 squared plus 9 minus 5 squared. 4 minus 6 is negative 2, 9 minus 5 is 4. Negative 2 squared is 4, and 4 squared is 16. 4 plus 16 will give us 20, so the distance from point L to point F is radical 20 in length, which is equivalent to 2 rad 5 or 4.5. Again, on your test, you'll be rounding to the nearest tenth, but it's important that you know how to convert between and simplify your radicals. Next up, is a triangle with sides 11, 15, and 19 acute, right, or obtuse? Justify your answer. So in order to determine which type of triangle this is by classification, we need to use the converse of Pythagorean's theorem. So we need to determine whether a squared plus b squared is less than, greater than, or equal to our third side, c squared. Now, the most important thing when you're starting out these types of problems is to determine which side is your hypotenuse. And that'll always be the longest side. So in this case, it's 19. 19 is our hypotenuse. So 19 will be on one side of the equation by itself. So therefore, we have 11 squared plus 15 squared, mystery 19 squared. From here, we're just going to evaluate. 11 squared is 121. 15 squared is 225. 19 squared is 361. 121 plus 225 is 346, which is less than 361, making this into an obtuse triangle. Because if the sum of two sides of a triangle squared is less than our third side squared, then the triangle is obtuse. All right, next up. Find the slope of a line that makes a 60-degree angle with the positive x-axis. So here's our x-axis. Here's that line L that's creating the 60-degree angle with the x-axis. So to get this started, we need to realize a couple things. First off, the x-axis and the y-axis, they intersect each other at 90 degrees. So we have a 90-degree angle here. Further, we're looking for slope. So we're looking for rise over run. Now, along with that, we have our 60-degree angle here. Now, if this angle is 60 degrees, that means that this other angle is also 60 degrees. And the reason for that is because they are vertical angles. And vertical angles are always congruent. Well, if this is 60 degrees and this is 90 degrees, there's no choice but for this third angle to be 30 degrees. So therefore, this is a 30, 60, 90 triangle. And as such, I can go ahead and draw my corresponding 30, 60, 90 triangle. So here we go. There's 60 degrees, 90, and 30. Opposite of 90 is 2x. Opposite of 30 degrees is just x. Opposite of 60 degrees is x radical 3. Now, at this point, I have 2 points on line L. I have this point down here where we cross the y-axis. And I also have my x-intercept here. So I can actually find slope at this point. Slope is equal to rise over run, which is also known as the change in our y value over the change in our x value. Well, the change in our y value from this green point to this other green point is x radical 3. The change in our x value is x. So therefore, our slope is x radical 3 over x. Well, if we look at this, we have x's on top and x's on bottom. They're both not underneath the radical. They'll cancel each other out, leaving us with our slope as radical 3. And that's our final answer. All right, next up. Let's go ahead and solve for n. To do this, we need to use Pythagorean's theorem. We have two sides of a triangle. We need our third side, and also this is a right triangle. That means we'll use Pythagorean's theorem. A squared plus b squared equals c squared. This gives us n squared plus 39 squared equals 65 squared. 39 squared will be 1,521. 65 squared is 4,225. Subtracting 1,521 from both sides will give us n squared equals 2,704. Lastly, we take the square root of both sides to get n isolated, and that will leave us with n is equal to 52. So therefore, our distance is 52. That makes sense because it is shorter than our hypotenuse, but it's also our longer of our two legs. Next up, we're going to go ahead and solve for a and b here. We would like to solve for the variable y. So we want to solve for the variable y in both of these. So for our first one, we notice that's a 30, 60, 90 triangle right away. So I can draw my corresponding 30, 60, 90 triangle. And looking at this, the side that we're given is 14. That corresponds with 2x in our corresponding triangle. So therefore, we can say 14 equals 2x. From here, we can solve for x, which will give us the bottom portion of our triangle, because we see that x is down below here. If I solve for x, I'll have our portion down below here. So solving for x, again, 14 is equal to 2x. That'll give us x is equal to 7. So therefore, the bottom portion of our triangle is 7. And then if I want to solve for y, well, y is equal to x radical 3, right? Those are the corresponding parts. If y is equal to x rad 3, and I know that x is 7, then y is equal to 7 radical 3. All right, next up on our next triangle, letter B. Again, we're trying to solve for y here. And looking at this, we also have a 30, 60, 90 triangle. Again, I see 90 degrees and 60 degrees. By the no choice theorem, this must be 30 degrees. So I can draw my corresponding 30, 60, 90 triangle. And then I can match up my corresponding sides. X radical 3 will, of course, go with 5 radical 3. Those two are corresponding parts. If I want to solve for x, then I just need to get rid of this radical 3. So I divide both sides by rad 3. And the rad 3's cancel, leaving us with x equals 5. Lastly, if I want to solve for y, well, y is equal to 2x, and x is equal to 5. If that's the case, then y is equal to 2 times 5, so therefore it's equal to positive 10. All right, and our final question of the day. Find w. So looking at this, we have 3 triangles here. They're all right triangles. And as such, we want to just find this little piece here, w. Looking at each of these triangles, I have at least two sides on each of these triangles, so therefore I can use Pythagorean's theorem for each of them since they're all right triangles. So I'm going to go ahead and start with this triangle on the top right here. So looking at this, I have a side length of 24, right? 12 plus 12 will give me 24. I have a hypotenuse of 25. So using Pythagorean's theorem, I have 24 squared plus f squared equals 25 squared. Again, I'm just calling this bottom leg f. 24 squared is 576. 25 squared is 625. Subtracting 576 from 625 to get f squared by itself will give me f squared equals 49. Lastly, to get rid of the square, I take the square root. Square root of 49 is 7. So therefore, this piece right here is 7 units in length. Next, we're going to go ahead and solve for this top left triangle. Just solve for this missing piece here. So looking at this top left triangle, I have the hypotenuse, 15. And I have a leg of 12. So again, I use Pythagorean's theorem. I'll call this piece, this missing part, a. So I'll have a squared plus 12 squared equals 15 squared. 12 squared is 144. 15 squared is 225. Subtracting 144 from 225 will leave me with a squared equals 81. Lastly, to get a by itself, I take the square root of both sides, leaving me with a is equal to positive 9. So I now have side lengths of 9 and 7. I just need the full thing now, and I should be able to solve for w from there. So looking for this full piece, I'll call this full piece t. I have two legs of this triangle, so I just need to find the hypotenuse. So this time we'll have 8 squared plus 15 squared equals t squared. Again, 15 squared is 225. 8 squared is 64. So 64 plus 225 equals t squared. 64 plus 225 is 289. And of course, we want to solve for t, so we take the square root of both sides, leaving us with t is equal to 17. So I now know the full length is 17, and then we have pieces of 9, 7, and w. So therefore, I can say w is equal to 17 minus the two sections that we currently have. Well, 9 plus 7 is just 16, so that's the piece that we currently have, minus the full thing of 17 will give us w is equal to positive 1. All right, thank you guys so much for watching today. If you have any questions or need anything, please let me know, but have a great rest of your day.